All right, let's go ahead and jump into these examples and hopefully bring everything together for you. So carefully look at what everything's asking you to do. So based on our last example, we know the graph of x squared looks like this one. It then says to sketch f of x plus 3. So if we look at all of our rules, what that means is to shift up, so this is a vertical transformation by 3 units because we're adding 3 to our function. So it says to select lattice points, and what lattice points are is, do you see all these little intersections of where our grid crosses each other? That's called a lattice point. So these points are called lattice points. I want to find a point where on my graph, do you see here the origin? My red line goes through a lattice point. And you want to pick about 4 or 5 of them. I can find 5 of them here. So those are my original points. And now I'm going to shift all of them up by 3. So this point goes up by 3. This point's going to go up by 3. 1, 2, 3. Right, 1, 2, 3. This one goes up by 3. This point goes up by 3 and up by 3. And this is how you do a transformation. We just shifted our entire graph up by 3. So let's review what we just did. We inspect it to figure out what kind of transformation we are going to do. We're going to write out what do we want to do. We want to shift up by 3 units. I find some good points on my graph, points that are at lattice points, and then I do that. I shift all 5 of those points up by 3 units, shifted them all up, and now I've transformed my graph. All right, let's go ahead and take a look at example B. Example B says that I want to subtract, I want to subtract 1 from my x values. But remember what that means is that h is going to equal positive 1. It's always a horizontal shift of the opposite. So if it says -1, we're going to say +1. All right, so what this means is we're going to shift positive direction, is we're going to shift the whole graph right, by 1 unit. So 1 step to the right. So I'm going to find those 5 points again. 1, 2, 3, 4, 5. And we're going to shift them. Okay, we're going to shift them all 1 unit to the right. So 1 to the right, 1 to the right, 1 to the right, to the right. Oops, it was a little low there. 1 to the right. Let's erase that guy. All right, and now I can go ahead and draw my curve in there. So make sure it's curved. It shouldn't look like a V. I know that's kind of hard to do. Oopsie, I just jinxed myself. All right, there's my curve. Good enough. All right, so everything's been shifted. So let's review again. You look at what they want you to do. Okay, you remember that if it's happening to the x, you've got to do the opposite, so a horizontal shift of 1, write out what you're going to do, find some good points, and then do that. Do it. Okay, next one. Okay, let's see, it's shown on the same graph. Okay, so this one, we're multiplying a 5, okay, we're multiplying a 5 to our function, our 0.5. on the same graph. So what does that mean? So this is actually one of those shrinks. Okay. So what this is going to be is a vertical shrink or stretch. I like shrink because if it's less than 1, it's going to be a shrink. Okay, by basically 0.5, which is the same as 1/2. So let's find those 5 points, and we're going to cut them all in half this time. Okay. So for this one, 0, half of 0 is still 0. So that one's not going to shift. But half of 1 is going to be 1/2. So I'm going to put a point right in the middle there. And then this one's at 4, so half of 4 would shrink that down. So I'm just taking all of my y values and multiplying them by 1/2. And you can see there's my new graph. I was trying to get them all in there. Okay. So I figured out what I was going to do. Okay. I figured out, I wrote it out, I found my points, and then I did what it said to do. Okay, so D is the humdinger. D is the one where we're going to put all of this together. Okay, so there's 3 things going on here. Oh, wait a minute. Oh, I take it back. It is not that hard. It says all we want to do, I thought this was a really hard one. I was like surprised I gave you one. All we're going to do is we're going to take this graph. See, this was a really complicated function, but we don't care. All we want to do is just reflect. Okay, it says just take that function and make it the opposite. So what did a negative do to our function? Remember, the rule is to reflect over the x-axis. So every single point is just going to flip over the x-axis. So this isn't as hard as I thought. So I'm going to find some good points. I've got a good point here and here and here. Those are all intersecting those lattice points. All right, those are my 5 points. Okay, we're going to reflect them over my x-axis. So what that means is because this point right here is at -2, 4, it's now going to become -4. Okay, so every y value is going to become the opposite. So see, this point right here is at 3. It's now going to move to -3. This point here is also at 3, so that means it's going to reflect to -3. Now this point's at 0. The opposite of, or the reflection of 0 is just 0. So it's going to stay there. And here we go. So it's going to reflect, the whole graph has just flipped upside down, and that's what a negative does. All right, there was a lot there. No way to speed that up, but let me know if you have any questions, and we'll see how you did. Our goals for learning for this lesson were: first, determine how a function transforms depending on how and where a constant is placed in the function. And second, to transform a graph of a function given a new function rule.